Hello, sir. My name is Parusha, and today I'm going to demo my Lab 9, which is linear regression lab. So let's start with the task one, which is understanding the dataset. So this is my dataset for the task one. So I'm gonna quickly explain what this dataset is doing over here. So the data set here actually is the script performs the following like sets. So first it's gonna load the CSV file. As you can see over here, it's gonna clearly load it. Then it's gonna skip the non-header columns, which means like no data header rows. It's gonna skip that and assign a proper column, which you can see over here. I'm gonna manually assigning the columns over here. As you can see, date, country, business type, breach, and all. Then it also gonna clean out, it gonna like clean out the records with missing or unknown total affected values. Then it's gonna also gonna convert, as you can see over here, it's gonna also convert the columns into numeric values using the label encoder, as you can see over here. And also it's gonna generate four plots to help visualize the data set. So the split, I splits the data set clean into 70% into training and 30% is for testing for later task. So let's quickly run the script first. Python 3 lab task1.py. Yeah, so as you can see over here, after pre-processing, I ended up having the 881 valid records that I used for like later on task like 2, 3, 4. And as you can see over here, it says everything like properly assigned, and it's gonna also see this after cleaning it having the sample encoding over here, and it created the four plots. So now let's look on the four plots. So for the plots, I'm gonna quickly go to the, yeah, this is my lab 9 screenshot. Yes, so these are my all the screenshots where you can see over here. I'm gonna start with the first one, not this one, not this one. Yeah, so these are the first screenshot which I am having. It's over here the number of breaches per country. So here the bar chart clearly shows the how many breaches occurred in each country. The United States here clearly dominates the dataset while the other countries appears far less frequently, and this tells the dataset is heavily skewed towards the US cases, which may affect the model generalization. So then let's go to the second one, which is the distribution of total records. Sorry, yeah. So here the histogram here clearly says how many records were compromised across the breaches. So the most breaches impacted a small number of records, as you can see over here, but there are several extremely large outliers, and this makes the data set very like highly skewed to introduce the large variance, and which can make the regression model challenging. So yeah, this is the graph I got. Then this is the average record compromised by breach type. In this bar chart, it displays totally like average total affected for each breach type. Some breach types lead to like much higher than average impact compared to others, as you can see over here, suggesting that the breach type affects severity, although the relationship is still not pure linear. And as you can see over here, the disposable tapes which are like leading the highest one, followed by the lost media, stolen tape, and fraud SE. Now let's move on to the fourth graph which I got. As you can see over here, this is a graph for breach type versus total affected. So here the scattered plot visualize how the total affected varies between the each breach type. So the majority of the points are very low with very extreme high outliers. And this confirms against that the data is noisy and contains many unpredictable spikes. So yeah, this is the first script for my task 1. Now let's move on to the task 2 before I'm gonna clear it. So get task 2 Lab09 task 2 a dot py. Yes, so this is the task 2 script over here. I have a long script for task 2 as well. So it has the same thing over doing. I have like selected the one feature X, then set the total affected as a dependent variable in Y, and feed the linear regression model using the training data. As you can see over here, I'm doing the same. Then I'm gonna again choose the predictor target, which is breach type and total affected area, dependent variance. Then step 2 is splitting the dataset. Again, I'm splitting the dataset into X and Y, and then I'm gonna build and train this model using the linear regression. And step 4 is gonna predict, and this is gonna evaluate the current R2 scores. And yeah, and I'll have the screenshots again. So let's start the task 2a, task 2a dot py. Yeah, so as you can see over here, I already ran it, and it's gonna show over here the I already ran and it was successful with the it's showing the simple linear regression with the intercept 91407.9403, slope is 33687.87, R2 test is minus 0.1828, and RMSE test is 22 million something. So yeah, so my first graph will be breach type model. So for the breach type, I'm gonna quickly show you how the graph is working here. In the first, I use the breach type as an independent variance. As you can see over here, was breach type as an independent variance, but the model produced like minus 0.18. As you can see over here, and RMSC was around 2.28 million. It was over here. Yeah, it was here. So now exactly in the plot, the actual value fluctuates significantly while the predicted data line is almost flat kind of thing. You can see over here the blue, like here is almost flat, and this shows that the breach type alone is not strong predictor for the breach size. This is the graph I got, and the second graph which I got is, let me show you the second graph. So the second graph I got is this one. This. Yes, so for the second graph, before I'm gonna start, I have a second, for the second graph, I will run the second script, which is for the different predictor. So for the second script, which is basically having the, I have choose the predictor which are inside out as an independent variable and total affected and a dependent variable. It's going to do the same, but I just change the predictor. So I'm gonna quickly run now the second one, which is B1 task 2b dot py. Oh, as you can see over here, so it's gonna quickly run the second script, which is inside out for and the total affected. In the second model, I used the inside out as an independent variable, as I told you, and the performance was even worse because the R2 is here is almost minus 0.47 and RMSC is like 2.54 million something. The actual versus predicted plot shows over here is like the very large mismatch, confirming the poor predictive performance. As you can see over here, comparing the both simple model, breach type perform slightly better than the inside out, like the inside outside, but both model fail to capture the real variation in the data set. And yeah, the main takeaway I can say is over here is a single feature is cannot enough to predict the breach easily and severity. So yeah, that's for my task 2. So for the task 3, actually task 3 is multiple linear regression and polynomial regression. So in task 3, I basically used the script that performs like three requirements. Mainly the first is multiple linear regression using business type plus data type. As you can see over here, which is multiple data type. I am using it here. These are the all, and I'm specifying over here, which is specifying the business type and data type here. And it's going, and also the multiple linear regression using the name plus country plus business subtype. So there are two different kinds of data, like multiple linear regression I am using, and also the polynomial regression from degree 1 to 4. It's gonna predict the degree, what kind number of degree. So the script will print evaluation metrics and generate the three plots over here. So let's start with the script. So yeah, as you can see over here, the script ran successfully. So the degree here is degree number 1, and as you can see over the best R2 and the best RMSE score over here. So for here you can see over each, like it's generated the graph for everything, like intercept coefficients and R2 test and RMSE test for MLR business, like with respect to total affected one, and also the MLR second plot, which is over from name plus country plus business subtype is equal to the total affected. So let's see the graph now. So as you can see over here, so the graph here is saying the actual versus predicted MLR, like business type plus data type, which is for the total affected. So the here the business type and data type are the predators, and it produces this thing, as you can see over here, and it produces this R2 test and RMSE, which is minus 0.55 R2 test, and RMSE test is 2610643. So the predicted values does not match the actual pattern, and R2 scores confirm as a poor fit, as you can see over here. So it's not very proper, so it's not matching. So now let's move on to the second graph we are having. So the second graph we are having is name, country, business subtype versus total affected. So for over here, the second model uses name, country, and the business subtype, and it produces the R2 value around minus 0.589, which is equal to minus 0.59, and RMSE is 2.64 million, equals to 2. So the plot again shows the prediction diverging away from the real values. As you can see over here, the plot is not matching. Even though with the more features, the model cannot capture the irregular behavior of the dataset. So that is the issue over here. Then we're gonna move to our third graph, which is best polynomial regression, which is degree 1. So in the polynomial regression, I tested degree 1 to 4, and the result shows the degree 1 linear has the best performance. Degree 2, 3, and 4 overfits the produce higher RMSE, as you can see over here in the terminal output. Degree 2, 3, and 4's RMSE scores are way higher than the first one. So the visualization shows over here the higher degrees generate a unrealistic spikes curves, as you can see over here, unrealistic curves, and which is classification like overfitting, and concluded that the degree 1 is the most optimal choice for the dataset. So that's for my task 3. Now let's move on to the task 4. Get 09 task 4. Yeah, so this is the script for overfitting versus underfitting. So what actually the script here doing is, the script changes the training split size to 20, 40, 60, and 80, and evaluates how the model behaves. So for each split, it gonna compute R2 score and RMSE score, and then it gonna plot both metrics in a single graph. So we'll get to know the how the working. So Python 3 Lab09. So I'm running, as you can see over here, it generates all training size at 20, 40, 60 and 80 with their R2 and RMSE scores over here. And it creates the plot as well. And the analysis, as the training size increase, the R2 score usually improves while RMSE decrease, indicating better generalization. However, if R2 drops or RMS increase, it shows overfitting. So let's move on to our results. So with this all training, RMSs are high and undertaking, as you can see over here. And with the larger training size, as you can see over here, 60 and 80, RMSC drop significantly, which is for better learning. And R2 stays close to 0 or negative due to the dataset complexity. So as RMSC is better metrics in this case because it directly measures the prediction error in the same unit as total affected. So final conclusion for this lab, overall this lab helped me understand how linear regression behaves on the real world and how to clean encode the categorized data and visualization as well. Thank you so much for watching. Have a good day.